Hello everyone. Welcome to my mini lecture. Today's lesson is testing and debugging of DC regulated power supply circuit. The teaching objectives are to understand and become familiar with the methods for measuring various indicators of a DC regulated power supply circuit and get to know the use of electronic instruments and apparatus. The key and difficult point is the methods for measuring various indicators of a DC regulated power supply circuit. During the operation, please follow the principle of safe use of electricity. Before powering up the circuit, ensure that there is no short circuit. When measuring, pay attention to the connection of the instrument probes or test leads in the circuit to avoid damaging the device. Question 1. How to check the soldering quality of the PCB? What are the criteria? Since the DC regulated power supply circuit for this task is relatively simple, with fewer than 30 solder joints, we can visually inspect the quality of the solder joints. The solder joints should be smooth, full, and shiny, without any cold solder joints or solder skips. Question 2. What checks should be performed on a soldered functional PCB before powering it up? Why is it necessary to perform these checks? How should they be conducted? Before powering up a soldered functional PCB, we should first check for any short circuits. Powering up a PCB with a short circuit can cause sparking, which may result in skin burns, or in severe cases, pose a risk of death or fire. The specific steps are as follows. 1. Before powering up the circuit, use a multimeter to check for short circuits. Set the multimeter to the ohms range times 1000 or times 100. Connect the red probe to pin 2 of the 3-terminal voltage regulator LM1085-5 and the black probe to the circuit's GND, and then observe whether the multimeter's pointer points to 0. 2. If the pointer points to infinity, it indicates that there is no short circuit. 3. If the pointer points to 0, it indicates that there is a short circuit, which should be found out. Question 3. How to find out the fault of the circuit? 1. Carefully inspect the circuit's solder joints again to check if any solder bridges are connecting the joints. 2. If no solder bridges are found, use the soldering iron to disconnect pin 3 of the 3-terminal voltage regulator LM1085-5 and the negative pin of diode D1 from the PCB, dividing the circuit into 2 sections for further inspection. 3. Measure the resistance across the terminals of the filter capacitor C7 with the multimeter set to the ohms range. If the resistance is not 0, it indicates that the rectifier filter circuit is not shorted. If the resistance is 0, it suggests that one or more of the 4 rectifier diodes may be shorted. In this case, remove the 4 diodes from the PCB and measure their forward and reverse resistances to identify the faulty component. 4. If the rectifier filter circuit is normal, measure the resistance between the terminals of the other filter capacitor with the multimeter set to the ohms range. If the resistance is 0, focus on checking the current limiting resistor R2 and the resistance of the LED D4 when it is offline. 5. If both sections of the circuit are normal, check the resistance between the pins of the 3-terminal voltage regulator LM1085-5 and the forward and reverse resistances of diode D1. Question 4. What indicators should a qualified DC regulated power supply circuit meet? How to test these indicators. Indicators that a qualified DC regulated power supply circuit should meet. 1. Output voltage stability. 2. Ripple voltage and ripple factor of output voltage. 3. Load regulation of the DC voltage regulator circuit. The methods and steps of testing parameters of indicators are as follows. After powering up the circuit, use a multimeter set to the DC voltage range to measure and record the output voltage at the output terminal under no load conditions. Attach a sliding rheostat as a dummy load to the output terminal and place an ammeter in series. Given the circuit's maximum rated output current of 3 amperes, adjust the rheostat until the ammeter indicates 3 amperes. Then, measure and record the output voltage again with the multimeter. Compare the output voltage readings between the no-load and heavy load conditions to evaluate the stability of the output voltage. 1. Ripple refers to the AC component in a DC voltage. Although DC voltage is supposed to be a constant value, any residual AC component due to incomplete filtering will cause ripples. 2. To measure ripple voltage, connect a dummy load to the output terminal of the voltage regulator circuit. Under heavy load conditions, connect an oscilloscope, set the Y channel to AC mode, to both ends of the load and observe the peak-to-peak value of the output voltage. 3. To calculate the ripple factor, first measure the peak-to-peak value of the AC voltage at the output terminal of the voltage regulator circuit using an oscilloscope. Next, determine the RMS value of this AC component. Then, use a multimeter set to DC voltage mode to measure the DC output voltage. The ripple factor is calculated by dividing the RMS value of the AC component by the DC component of the output voltage. 4. For circuits supplying multiple modules, apply the above method to measure the peak-to-peak value at each module's power supply terminal and calculate the ripple factor. The load regulation of a DC voltage regulator circuit is closely related to its output voltage stability. To test this, connect a sliding rheostat and a current meter in series at the output terminal of the DC voltage regulator circuit. While adjusting the rheostat's resistance, monitor both the DC voltage changes measured by the multimeter and the temperature rise of the heatsink on the 3-terminal regulator. Significant drops in output voltage and excessive temperature rise of the heatsink under increased load indicate poor load regulation of the power supply circuit. In this lesson, by learning the testing and debugging of DC-regulated power supply circuits, we have improved our knowledge and understanding of power supply circuits and familiarized ourselves with the use of various types of electronic testing instruments and apparatus. Here are 2 questions for your discussion after class. Question 1. Why is it necessary to test the load regulation of a DC voltage regulator circuit? Question 2. How to calculate the ripple factor of the output voltage of a DC regulated power supply circuit? That's the end of this lesson. Thank you for watching.